Hello, this is Kyle, and this is my presentation of homework number 3, graph visualization. I chose some Facebook network data, and I downloaded it from Stanford's network analysis data site. And I've imported the edge list called zero.edges. These data were collected using a Facebook app and were used in a 2012 research paper. This particular edge list contains 333 distinct nodes and more than 2,500 edges. Edges are single relationships between nodes. They're also called dyads, and they're the basic unit of social network analysis. This particular edge list does not contain any additional attributes or weights, as you can see here. Moving on to some graphs and metrics. This first graph is of the entire network data set, and you can see that nearly all of the nodes are connected except for some little groups along the edges. Now, one of the things we can use the NetworkX package to do is to calculate or is to show the path, the shortest path between two nodes. And so let's say we tried to find the path between node 35 and 256 over here. Now, if we try to do that in Python, it will return an error saying that, well, these two nodes aren't really connected. However, if we tried the same with nodes 233 and 256, Python will return the path, and it shows that they are directly connected. And in our next set of graphs, we can take a closer look at the 5 subgraphs that make up this data network. We can see that nearly all but 9 of the nodes can be found in the largest subgraph right here. And then there's just 9 others that form little groups off to the side. Now let's take a look at some metrics for the largest subgraph. The average shortest length between the nodes is 3.8. Also within the largest subgraph, we can calculate the diameter, which is the maximum distance between two nodes, which for this particular graph is 11. Next, let's take a look at some traversals. The next graph shows a depth-first traversal, which means that we visit the child nodes before visiting each of the sibling nodes. And in our final graph here, we do a breadth-first traversal, where we do the exact opposite and visit the sibling nodes first, and then go back, and then go and visit all of the child nodes. Well, thank you for listening to my presentation.